Hi, just wanted to walk you through this one. Had a couple people ask me about the last problem to do it, so I got it up on the screen here. I got the points plotted. So this would be A, and then basically there would be B, there would be C, there would be D. What kind of figure is A, B, C, D? So the lesson that I'm having as a geometry student is, can I take 4 points from space and tell you what shape it is with evidence and reasoning? All right. The first thing I do is the eyeball test. When good old eyeball test, I look at that shape and I'm like, Look, at first I thought it was a kite, but then I was like, I think actually these things might be parallel, right? So here's my question. I'll use my laser to help you. Everyone take your eyes and look at AB. Is that indeed parallel to this? I'm wondering that. And then is BC parallel to AD? And then if it is, it's a parallelogram. And then once I know it's a parallelogram, what type of parallelogram would it be? All right. How do I do this? Nice. I basically analyze the slope of AB. I analyze the slope of CD. How do I analyze any slope that's on a coordinate plane? I basically just look at its good old taxi cab movement. All right. So in terms of taxi cab movement, how much up did I go in green and how over did I go? Good. We'll always call that delta y and delta x just to keep referring that. So you've learned that all through math, and now you can kind of lock that in and keep that going. I know this is up 10 and I know this is over 5. How in the world did I get that 10 and 5? That's a great question. People who are lost, that's a point where, like, man, where did those numbers come from, right? Never be afraid to ask questions like that. They came from just where the ordered pairs were. So I just wrote them in green. I can clearly see this now, basically that this is at my laser pointer. That's at -5. I'm just looking, what's the horizontal movement, right? That got me to B. So if I travel, basically, if I'm here, what's this horizontal movement, right? And that's basically 5. And I'm getting that just from looking at those coordinates, right? Now, same idea here, right? This is at 0. And how far did I go up until I hit that top of that? And that's 10, all right? So neat way to write this now. Here we go. Zoom it out just to help us a little bit. I'm just going to clear this thinking just to clean up my problem. I basically now know that this is positive 10 over 5, and that's 2. And I've been kind of teaching you a new word. That's called the gradient, right? It's the rate that the segment's moving at. That's 2. Therefore, now I go to look at CD. So if indeed this thing is 2, these are parallel. And that's my big battle, right? And again, now let's look at all the ordered pairs. So here we go. This thing is down here at -10. So this would be 0, -10 in terms of my XY coordinates. And this thing would be at 5, 0, right? And so I'm going to just go dotted line this way, dotted line that way. And then I'm wondering, what's that relationship? Again, what's this? That's 5. And what's this? That's 10. Okay. Now, some of you are going to probably wonder, wait a second, is it -10 or is it 10? And in terms of this, I don't have to worry about negative and positive, just because I'm literally using it as a triangle. Basically, I'm looking at this like a triangle. So basically, it would just be 10 units, and this would be 5 units. Now, when I want to talk about an algebraic slope or the gradient, then I'll take that positive, negative idea into play, okay? So I've got basically D going to C, and I'm now knowing that that's 10 over 5. That is 2, and to help you, I put a little triangle like that, and that's the idea of that's a gradient. So now I'm looking at this, I'm going to unzoom it and look at this entirely. I know now basically that the top A to B is 2, the bottom C to D is 2. I could make a wonderful geometric statement that indeed AB is parallel to CD because they have the same slope, right? And you get the idea then. These 2 lines are running parallel, which means they're never going to hit, right? These 2 lines will never intersect each other. Lesson that I just gave from the last video, if you watched it. If I calculate this slope right here, and it is an opposite reciprocal to 2, that would mean this angle is 90. So if indeed this thing is an opposite reciprocal, it means that is going to be 90 degrees, okay? So let's keep that in mind, that the slope, technically to really help us too, here we go, just to really kind of force us, it's 2 over 1, right? So that'll let me analyze that. All right, so here we go, this guy. So I'm going to start at B. I'm going to basically start at B. I'm going to calculate down to C. Taxi cab movement. What did you go over and what did you go down? How many units have you moved? I use the ordered pairs once again. I know that this is 5 and this is 10, right? And again, that's going to be just units because I'm looking at it as a triangle. Now, when I want to talk about the gradient, the slope of BC, now I'm going to talk about negative and positive. And the line is going in a downward direction. So therefore, that's going to be negative 10. Over 5, that is negative 2. All right, so now I have this concept right here that I'm going to unzoom it all the way for us to see. I now know that this line right here is moving at a rate of negative 2. This line is moving at a rate of 2. These are not opposite reciprocals. They just happen to be opposite. Like this guy is 2. This guy is just negative 2. Not reciprocals. Close. Well, I mean, they're the same, just going in different directions, but that idea of being an opposite reciprocal is how I know that would be 90, okay? Thus, I could say this. This angle C, I know is not 90 degrees, okay? And I could basically just go, I showed this last class, I can just go 90 with a slash, right? Don't need to, but I just can just to help me learn, okay? Here we go, last little step. If this is negative 2, and this guy is negative 2, it's a parallelogram. Now, if A to D, my little laser going back and forth, A to D, is anything other than negative 2, it would mean that basically this and this are not parallel. And if I would have a shape with only one set of parallel sides, that'd be a trapezoid, right? So now I just go down, I look at this thing. Is this thing going to be negative 2 or not? I think some of you already figured this out very easily. This is basically 10. This is 5, right? Now in terms of gradient, I got the gradient of A to D. That's negative 10 over 5. That's negative 2. Therefore, I have another conclusion to write. I have AB is parallel to CD, and now I know that AD is parallel to basically BC. I've got 2 sets of opposite parallel sides. Because of these beautiful geometric claims, I know for sure you're a parallelogram. It's the definition, right? It's the entire definition of exactly what a parallelogram is. 2 opposing sides, opposite being parallel to each other, all right? What type of parallelogram is it though? So if you wrote parallelogram, I'm actually super happy. I mean, that's great. Even if you didn't show any work, at least you thought about it and said, oh, Mr. Yates, it's a parallelogram. But is it a special one? Is it something more? I got options. I got square, I've got a rectangle, and I got a rhombus. And basically, I already know it's not that because I know about opposite reciprocals. I know about slopes. I know how to analyze something, and I can tell you if things are 90 or not. Nice geometric knowledge that is to kind of just lock in my brain. Okay. Question for people: is it a rhombus or not? Oh, look at that highlighter. That was ultimate backfire. Let's try orange. There you go. Oh, sort of, kind of works. My wife would be happy for orange. She's a Denver fan, and that's a good old Denver, Colorado color. Not to get sidetracked. It's hard to sidetrack me now when no one's talking back to me. I have to sidetrack myself just to show you how that works. All right, here we go. How do I know if it's a rhombus or a parallelogram? If it is a rhombus, and here we go. So if I'm going to put this in, let's do what new color could we do? I'm going to go with let's go with gray. See if you can see gray on my screen. If this and this and this and this are congruent, if you can see those gray marks, I know it's not the best color, then for sure this thing is a rhombus. So are these all the same or not? How do I find the distance of any line segment on a plane? I basically now just look at it. I'll just use this example right here. This is a wonderful right triangle. And because that's a right triangle, watch what I can do. I can put a little 90 right there, and I can go 5 squared plus 10 squared is equal to BC squared. And then I can figure out that length. That's 25 plus 100. That's 125 is BC squared, right? Thus, to continue that work, I basically now know that the square root of 125 is indeed BC. So BC is the square root of 125. Gotcha. I'm not going to reduce it, and I'm going to show you why in a second. That's interesting. So this was 5 and this was 10. This is 5 and this is 10. Oh, it's got to be 125. Square root 125. Same pattern. 5 and 10. Square root 125. Square root 125. I now have some evidence that these are all the exact same length. So, class, this is indeed a rhombus. Okay? And basically, all your homework was like that. It was, can you see these ordered pairs? Can you see these? Can you graph these? And can you show me a lot of work? And look at this word right here, justify your conclusions, okay? You don't have to use the midpoint formula. You don't have to do the distance formula, because that's just kind of, I would consider that just routine, just procedural work. Look what you've done. You've taken a much higher level of thought to this. You're saying, I'm going to analyze it with slopes. I'm going to tell you about the rate of change of these items, and because I can tell you about that, I can tell you what shape it is, okay? Find the coordinates of this. And the reason I wanted to do this, guys, is I wanted to show you how to find the midpoint, okay? So basically, I'm going to scrap all this work. Neat to see it go. Goodbye. All that work would be so valuable, right? And if I take it away, you can see. If I don't see how you can think, it's hard for me to understand if you learned or not, right? All right. So here we go. A to B. So there's my B up here, right? And so now I'm going to just show you this idea of how you find the midpoint. How do you find the midpoint? This is a great, great moment on how you find the midpoint. How does one find the midpoint of something like this? Let's just think. I could always show you a formula, and then it's just plug and chug, but I can actually show you how to think it through. So watch how we can think. That's why I love doing this, because you're going to a higher level of thought. There's my taxi cab movement. 10, 5. What's the idea of a midpoint, right? The midpoint is the perfect middle. So watch this. Let's find the perfect middle of my rise. That would be 5. 1, 2. So basically, here we go, right? 1, 2, 3, 4, 5. I'm going to draw a line straight across like that. Pretty neat idea. Okay. What's this? This is 5. So 1, 2.5. So I'm going to draw a line right at 2.5. And you can see I almost cross-haired it up. I was really, really close, right? I'll try to pin there. We go. Pretty neat idea. That basically, I just said this. Take your delta y, cut it in half. Take your delta x, cut it in half. That's how you find the midpoint. Therefore, this has to be the midpoint of that. And that's how I find midpoints. Challenge I now invite you to try to do is find the midpoint of each of these. Construct that shape. So basically now I'm going to do it just a little faster, right? I'm going to reconstruct my shape. I think sorry. I'm going to reconstruct my shape and say, if you find all these midpoints, right? What new shape would that be? If you connect all these midpoints, I knew something was off. I could just test. Good old eyeball test, right? I'm pretty sure I went to 4, not 5. 1, 2, 3, 4, 5. Yep. So I want to go from there to there. That's 5. And there we go. So now, if I find the midpoint of each one of those, connect that, draw that shape, see what that shape might be. See if you can put all of our learning together, okay? And I'll give you the solutions here in just a little bit, but there you go.